Well, hello friends. Welcome back to Browser Hacking. Today we're going to continue working on Discord support in Serenity OS. And I got this message from Ben, who has been helping with looking into what Discord is doing. So he said that he did some more digging and it looks like the app depends on local storage to function properly. It will let you log in fine without it, but that is where the app saves persistence. So the actual Discord web app is unable to load your login state and will then send you back to the login page again. So Ben says that a basic local storage implementation will be required for the Discord app to function. So super big thanks to Ben and everybody else who's been digging into Discord. Today we're just going to take Ben's suggestion here at face value and start implementing some local storage stuff. But before we do that, let me just show you where we're at visually, because there have been some improvements since last time. In particular, the SVG rendering has been improved by Sam, who tracked down some bugs in our path rendering code. And as you'll soon see here, we're actually pretty dang close to perfect. Let me open it up here in Firefox for comparison. So let's scroll that thing out of the way. Yeah, look at that. I mean, we still have aliasing artifacts and stuff, but I have to say it is pretty close. We're missing the little circles, actually, little white dots on the shoes and stuff. But yeah, we're moving forward, making progress. Also, look at the absolute wild number of people on the server at this point. It's so weird how quickly we grew after we moved to Discord from IRC. Anyway, so today we are going to work on local storage, as I said. But thank you to Sam for improving SVG, and to everybody else who were working on things in the background as well. So let's see, local storage. Yeah, so let's just go get a basic idea of what this API looks like. We already learned in the first video in the series that they are testing for the presence of window.localStorage, but they were not failing the load if you don't have local storage. But it sounds like even though they don't fail the load, they later on will assume that you have local storage, right? So I guess, as I understand it, I've never used local storage and I've never worked on it in any way. So this is kind of new to me, but my understanding is that it's some kind of a key value store, basically. And that it's supposed to be persistent. So like if you close the browser and reboot the machine, then stuff would still be there. Now, I think we're not going to do persistence from the beginning. Rather, we will just build something that's sort of bound to the current process. So, and then we can, once we have something that works, then we can look at how to persist these things. But just to get something up and running, let's build a session-bound storage, I guess. Maybe not unlike session storage, which is supposed to be a separate API. Session storage. Actually, maybe they are this. Did they give you the same type of object? Session storage. Oh, so local storage is a storage and session storage is a storage. That's kind of cool. Okay, so one API, but we're just going to implement it without persistence. So let's start by just adding the IDL file. Actually, does this go in a new directory? No, this is part of the HTML spec. So HTML, storage, and then we'll add the basic CPP class for it. And also right here, HTML, storage. Storage. All right, so this is the thing that we're going to implement, storage. And then it should be exposed on window, I guess. So A little bit of dancing around. The window object is special. We don't have IDL for it yet, which is unfortunate, but that's not something we're going to fix right this very moment. So I'm just going to go ahead and add more ad hoc properties. So local storage getter, something like that. And we can also add session storage, I guess. Or you know what? Let's focus on local storage first. We'll have plenty of time for session storage in the future. Function local storage getter. Okay, then I forget how to write one of these. Okay, that's not so complicated. We just define a native function, window object, local storage getter. And then we get the C++ object for the current this value. And then we want to return wrap. We want to get the local storage object, I guess. So is there always a local storage? What's a local storage holder? A local storage holder is null or a storage object. Okay, well, one thing at a time. So document has a local storage holder. Okay, well, we'll get to all these things. For now, we're just gonna do this, and then the window class function called local storage will have to figure out exactly what checks need to be made and so on. So storage. Okay, sure. Libweb forward. Let's go ahead and add it to the forwarding header as well. Storage under HTML. Taking care to keep everything alphabetized, of course. Very important stuff. By the way, since we are touching all these headers and we have to rebuild anyway, why don't we juice up the copyright date a little bit? That's always nice. I mean, it is 2022 after all, so let's see. Let's see what goes into the storage IDL. This guy right here. All right. Okay, so we have a pretty basic API. Storage has a length. So I guess that's the number of keys. And then you have a key getter, which takes an index. And then you have a get item that takes a key, a set item that takes a key and a value, and a remove item that takes a key, and finally a clear. All right, so length, I guess, it's just a key value storage, and this is the number of key value pairs. This is an index, like you can index directly into the key array. Okay, and then there's getter, setter, and deleter. So you can access it via subscript operator. You can use JavaScript delete to remove keys. I don't think we've implemented ideal deleter I don't think we have code generation for that, so we'll probably have to do deleting, either implement it in the IDL library or do a custom override of the JavaScript delete operation. But either way, maybe we don't even need to do that today. If we just do, like, we can do the basic function calls, not so much the getter, setter, deleter stuff yet. I don't know. Just trying to scope the work a little bit, I guess. So these are our APIs that we want. So storage.h. No copyright available. Wait. Oh shoot. I think I must have reset my CLion since last time. So let's create a copyright configuration. Can I make one? Wait, how do I do one? Copyright profiles. I don't remember how to do this. Let's see if this works. Dang it. That's not what I wanted. Shoot. That's not the right comment formatting. So, formatting. Oh, here we go. Oh, this is the one I wanted. Wait, is that what we normally do? It's like one too many lines. Dang it. Oh, that was my bad. I put a new line at the end there. Okay. Looking nice. Real nice. Okay. So, name spec web HTML class storage. Cool. And a storage, I guess, at the very least, will need reference counting, since it can be referenced by JavaScript. So, ref counted. Yeah. Sure. And what was the list of APIs? Right here. These are the boys that we're gonna need. So a length getter. Let's see, key. What are we gonna call this thing? Keys size. You know what? Let's put these things out of line. Then I don't have to keep rebuilding everything, including the header. Get item. Sure. Just doing a little bit of manual translation from IDL to C++ here, and we are good. And then let's see, storage. Then let's have some kind of a function that creates one, I guess. So non-null ref footer. Storage create. And then I'm sure that like when you actually access local storage, we have to do some shenanigans to get the origin storage for that. Yeah, the storage object associated with Windows, origins, local storage area. Local storage bottle map. What is a bottle map? Given an environment settings object and blah, 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 blah. Okay, yeah, so we're still waiting for the environment settings object PR to go in. It's not quite merged yet, Or at least not when I started. When I started recording the video, it didn't go in yet, but it seems like somebody merged it 2 minutes ago. So thank you, Linus, for merging that, and Luke for working on it. Really glad to have that in. So that should be cool, but if I pull that, it would totally mess up all of my local hacks that I have for the recording. So let's just ignore that for now anyway. And let's focus on the basics. So just making the simple storage, and then we'll want to have a simple test page for this, I guess. So local storage HTML. Yeah, so what do we want to test here? Something like local storage. And then let's put something in there. So set item. And these are all strings, so it's going to be saved as strings. Let's try this. Console, or no, let's see. Yeah, let's do console.log. That's the easiest. Length. Key 0, 1, and 2. I don't know if these are supposed to be in order. I guess we'll learn that eventually. Get item. Yeah, and then let's get them in reverse order and see what happens. Let's see if that works in Firefox, first of all. Oh, wait, I was I was writing the code with Serenity coding style. I forgot about JavaScript camel casing. Oopsie boopsie. Well, it's easy to get these things confused sometimes. All right, let's try that again. Length is not a function. Oh, it's just an attribute. Okay, sure. That's fine. There we go. So it dumps out the keys in order. Length is 3, keys in order, values backwards. Yeah, so we should be able to make this work in Serenity as well, I would think. So let's focus on doing that. Also, wait, why did I make the copyright say 2020 through 2022? That's not actually what I wanted to do. I wanted to do that. I don't like to backdate new code. That feels weird. So here we are. Libweb HTML storage, sure. Storage. Should probably declare a destructor as well. Then it should be non-movable, non-copyable by default. Yeah, because we inherit from ref counted, then we get non-movable, non-copyable by default, of course, as usual. Just validating because I suddenly felt suspicious. Okay, so what kind of stuff do we have here? Just flesh this out a little bit. La-da-da. All right, so length, that was easy, but let's be diligent here and we can be diligent and just copy spec links because why not? This is maps size, storage proxy map. Equivalent to a map, except that all operations are instead performed on its backing map. Which allows for the backing map to be replaced. Okay, well, some ongoing spec work there. For now, we are just going to say that, well, we learned one thing here, that we can call our backing storage a map. And they want us to have a backing map. And a map is an ordered map, or sometimes just map. So we want to have an ordered map. A finite ordered sequence of key value pairs. Sure. And we know from observing the API here that it's 2 strings, string key, string value. So this would be an ordered hash map in our case. Of string to string. Let's just call that map. Return and map size. All right, one API implemented. Next one. So then we had key. All right. So copy spec link, put here. And then the steps are, if the index is greater than or equal to this map's size, so if index is greater than or equal to map size, return null. So that's a null string in this case. Incomplete type ACK string, sure, let's include that. And then let keys be the result of running get the keys on this is map. So keys is mmap keys in our case. That's just it will give you a vector of all of the keys in the map. So pretty straightforward. And then finally 3 is return keys at index. Cool. So that's another one down. And then we have get item. Oh, supported property names on a storage object. So it looks like we have to allow you to access, you have to be able to do stuff like s.to, for example. Named access, named property access. This should print out named property access :2. Yeah. So that's something that we have to support as well. So this thing is pretty tightly integrated with the JavaScript language, actually, which is cool, but also a bunch of extra work for us. So that was get item. Next is set item. Oh wait, shit, no, that was key. Next is get item. All right, no need to get ahead of ourselves. So if it does not exist, then return null, sure. So we can do something like this. Auto it is find key if it is mmap and return null string. Otherwise, return it value. No, or yes. That would be the right thing to do. Okay, and then we have set item. This is very straightforward so far. Of course, we are, skipping over a lot of this is probably the easy part. There's other tricky stuff coming up, I'm sure. Okay, and then let me just tighten this up a little bit. Oh, not quite right. there was an indentation there, so 1, 2, 3 sub steps, and then back on track. So let old value be null. I'm assuming that it's going to be a string since we're talking about values. Reorder is probably Boolean since it's true. And then if mmap contains, or you know what, let's not do a double lookup here. Let's just do a find key if it is not mmap end, then do stuff. Old value is map like that. If old value is value, return, because then that's a no-op. Set reorder to false. Cool. Sure. If value cannot be stored, then throw a quota exceeded error DOM exception. So I guess that's going to be a fix me because we don't really have a quota. But I mean, at the same time, or no, let's not get carried away with inventing crazy things here. But what we can do is for set item, so set item can throw. So DOM exception, or that's basically what I wanted to get to. Oh wait, is it just called exception or? Maybe if I spell correctly. Oh, that's better. Yeah. So it can return a DOM exception, but in this case, there's no DOM exception. Here, let's just leave it like that with a fix me. Set, this is map key to value. So mmap. Actually, we can probably scope this thing here. Okay, so mmap set key value. If reorder, then reorder this. Okay, and then broadcast this. What is reorder? To reorder a storage object, reorder storage's maps entries in an implementation defined manner. Okay. That's implementation defined. So note, this is implementation. Yeah, well, actually, let's copy that verbatim. I guess this is sort of the HTML spec way of saying that the order here doesn't matter. So like, it basically means like you're allowed to randomize the order of the storage keys at this point. Which tells me that there's some browser out there that implemented this without using an ordered hash map and just used a regular unordered hash map. And then the artifact in the spec here, basically, they have to come up with like an operation in spec language that means like, oh, and then you can just randomize the order, whatever. Because they note that here that it is unfortunate, but iteration order is not defined and can change upon most mutations. So, yeah. This basically means that we're allowed to, that we're not required to maintain insertion / iteration order, any particular iteration order. Yeah, a little bit weird, but okay, sure. So you could argue that like maybe we should just lose the reorder stuff, but I like it for clarity at the moment. And then maybe, you know, maybe I'm misunderstanding something, and we'll figure out later that I misunderstood something. So let's just leave it at that for now. And then the final step was to broadcast this with key, old value, and values. What is broadcast? To broadcast a storage object storage given a key, old value, and new value, run these steps. Okay. So I'll set up some state, and then for each remote storage of remote storages, remote storage. That's all storage objects, excluding storage whose type is storage's type. So it seems like I have to send storage events out. Okay, I'm gonna put a fix me here for the broadcast, because I guess this is about interaction between storages. Yeah, let's just leave that as a fix me for now. Don't have to do everything at once. Next step was remove item. So that was this guy right here. So another fascinating function that presumably removes something from the map, but let's still make sure that we do it according to spec. I think it's universally a better idea to do it according to spec because there's just less room to mess up. And like, there's a time and a place to deviate from the spec or to like find your own way of implementing stuff. And the main place for that is performance, I would say. So like if you can sacrifice some amount of like spec/implementation lookalikeness or similarity in order to gain large amounts of performance, then that's something you can consider. But like so far, this doesn't seem performance sensitive enough to, certainly not yet, to justify thinking about alternate approaches. Map end. Yeah, so return null. Wait, remove item, return something. Wait, does it? Remove item. Return null. That's weird. It doesn't have a return type in the IDL. Did we find a spec bug, I wonder? Let's see. Let's try what happens if we delete something here that is not in the map. So let's do a console.log s remove item, something that's not there, not here. And what do we get in our console? Undefined, not null. So that to me seems incorrect. Yeah, so let's report that. Dun, dun, dun. The remove item key method tries to return null despite not having a return type. Oh, that's so messy. Let's see. Oh. Can I paste without formatting? No? Okay. If this is map key does not exist, then return null. The return seems wrong here, since the method is only used by storage. Remove item. By this API. Let's see. Man, these are so... I mean, bless them for trying, but they're really messing up my formatting with that stuff. Although I wonder if a deleter, like maybe the part that I'm missing here is that a deleter still needs a return value. Have to look that up. Deleter. Named property deleters? Sure. Okay, name properties, so you can delete them and perform the steps. If the steps indicated that the deletion failed, then return false. Okay, so maybe it's for this algorithm actually, like the internal delete algorithm of WebIDL. I'm not confident. I'm not confident that it's a bug based on the fact that it's a deleter. So okay, let's not get sidetracked with that. I'll have to investigate that in more detail later. Let's see. So where were we? Remove item, right? Well, right now we don't have anything meaningful to return here. Fix me. Return null. Yeah, that's a question mark for the future selves. So what were the next steps? Oh, they say right here, actually. So IT value, sure. And then remove it. And then reorder this. This is implementation defined, yeah. Broadcast this with key, yeah, so that's a fix me as well. We could also do something silly like this, right? Reorder. Or we could then put the comment in there instead. Yeah, we can do this. That's also okay, I think. It's a little bit weird, but in the interest of sticking close to spec, and I have a feeling that Linus is going to tell me that I'm being a little bit silly with this, but then let him do that. Finally clear. Okay. So clear has some very easy steps. Clear this as map and then broadcast null, null, null. So maybe we should actually implement the broadcast API, but just put a fix me inside of broadcast so that these don't have to have fix me's everywhere. clear. Oh, broadcast. Yeah, because the API is really simple. It just needs broadcast. Needs a key, old value, and new value. So this we can definitely put in broadcast. Sure. All right. Key, old value, and null. Okay. I don't know if broadcast can throw. I didn't check. I think it can't. Yeah. So let's put that here. Yeah, this is a fix me to implement. Implement. All right. We wrote the very first storage object. Cool. Let's see if we can make DOM window return one of these thingies. So what we care about is handing out a local storage object, and I guess it should hang on the document. Let's see. So when you call local storage on window, we were supposed to, okay, let's start in window.cpp. Ref footer to HTML storage. Okay, so copy this thing. Oops, that's not what I wanted to do. Okay. So we are just gonna be real simple here and fix me implement according to spec. So I think what we'll do here is we'll just throw in a something simple like we want to have a storage per origin, right? So we'll just make a totally ad hoc map. We have origin and we have HTML storage. Local storage per origin. All right, it's a start. And then sure, how does this work? And then you provide the active. Wait, how did we find the document? Document, associated document. Dot origin. And then this is a construction callback. So we have this API in our hash map called ensure. And it's a bit like a getter that will construct an object. If the key is not present in the map, it will construct a new object in this callback here and then insert that into the map auto magically. So I guess what we want to do here is just make some kind of a HTML storage create, which I feel like I added, although I never implemented. Oh, and I have to say what I want to return here, or, well, do I? Maybe I don't. Yeah, I mean, this is obviously totally ad hoc, just making something, and then we want the window object CPP to have the storage header as well. I feel like I messed something up here. Yeah, some kind of copy paste error. Okay. What went wrong? Oh, we don't know how to hash origins. Okay, that's kind of sad. Origin doesn't have a hash function. Oh, we can add a hash function for origin, no big deal. So hash traits. Wait, how do we add traits again? It's been a while since I added traits for something. I guess these, something like this. So web origin so how do we hash one of these things? It's going to be a mishmash hash of the origin dot host dot hash and a mixed hash of, oh wait, we have to pair int hash. So port host and let's also mix in the protocol hash. Okay, well, that was a bit gnarly, but hopefully we got it right. Also, now I'm building with -k, so we'll just continue in order to progress the build a bit more so that we don't have to keep rebuilding if we can get some work done in the background. Local storage. Oh, wait, direct property. That's not what I meant to say here. I wanted to add a native accessor. Duh. Okay, no operator to compare our origins. Origin doesn't have a comparison operator, I guess. We have is same. Which I guess is the thing that we want here. So we can just return that. Yeah, origin.h gets included, I suspect, kind of globally-ish through, or I don't know, actually. What else don't you like? Wait, did you not like that? Oh, it's about something else. No wrap function for local storage. Okay, sure. Totally forgot that I have to add information about the bindings. So we need a storage wrapper. Sure. Wrappable. I'm just gonna copy paste a little bit of code here. So libweb bindings wrappable. Okay. We probably need to provide our own wrap function. So JS, yeah, something like this we need to make. Okay, a little bit of busy work here. I'm probably gonna be on the hook to include this somewhere. Also, do I need to expose window.storage? Yes, of course I do. All right. Yeah, no matching function for call to wrap. Of course, we have to add it to the wrapper generator. More hard-coded includes for the wrapper generator. So that was in... Actually, wait, hold on. This is not going to be used by the wrapper generator in this case. For once, we get away with it because of window object not going through the wrapper generator. We can actually get away with a bindings storage wrapper right here. Although we should still expose it on the global object in window object helper. Storage constructor and storage prototype. Okay, sure. Did I do something stupid like not put a pragma once? Yes. Okay. Lots of small mistakes today. So let's implement that create factory function. And then see what else we messed up. Window object CPP. Still no wrap. I guess because it's here. Wait, why wouldn't it see that? Window object CPP. No wrap for this. Because I'm not starring it. Poof. There we go. Yeah, this thing is gonna local storage may throw to deal with that here. I think it may throw, right? Yeah, it can throw security error, for example, but we're just papering over that right now, or skipping over it, but it's something we'll have to come back to sooner or later. Anyway, it would be nice if you would build now. This has been a very unclean editing session so far. well, for moving forward, it would be real nice if our test page could work, although the name property access is definitely not going to work. So out of the things we added here, this thing is not going to work because you can't do this. Okay, what did we screw up? Finally, storage wrapper.cpp supported property names. Oops. Why do you think I have that? Oh, because of getter and setter and stuff, and deleter, or well, supported property names. Okay, so there is actually some ideal integration with these concepts. At least getter and setter, I guess. Maybe not deleter, but supported property names, we can definitely implement that. That's so cool that somebody did that. Supported property names. Who added the code to support that? Is that you, Luke? It may have been Luke. My man, Luke. Luke is doing a super awesome amount of work on the browser, which is really awesome. It's really fun to see how many people are hacking on the Serenity OS browser and JavaScript stuff, and very few of whom have prior browser experience. So like a whole lot of people have become very competent browser developers just from hacking on this project. I think that's amazing. And I'm really proud of everybody, because it's not an easy thing to get into, but it is possible, and they are proof, I guess. So let's add that thing. What did you want that to be, by the way? Supported property names is a vector of string. Sure, we can do that. We can definitely do that. Although it feels a little bit like something that didn't have linear access time might be a better return type for an API like this. But that's not what we're here to look at right now. In fact, I guess this is just the map keys, right? Also, was this, I feel like this was even in the spec somewhere, and I was actually looking at it at one point. Supported property, aha. That's so cool that it actually says right here. So let's note that. Yeah. All right, what else? Get item. Oh, we need, wait, hold on. Hold on. HTML storage as this discards qualifiers. What's going on in the wrapper at 155? Impl.getItem. Why is it const? Because we are in legacy platform object getOnProperty for getOnProperty slot. Aha. Okay. So getItem is const, or the impl here is const, but getItem is non-const API. We can certainly make it a const API. I think it should have been in the first place. So that should maybe just work if we switch it up consistently. Yeah, the const correctness in libweb and libjs is so much better than it is in WebKit, which I worked on for many years before. Const correctness in WebKit has always been sort of an afterthought because it's a, you know, it's a legacy code base. And at one point we started like retrofitting const correctness to it. But, and I don't know what state it is in these days, but last time I worked on it, it was still like an uphill slog to make things const correct. And there's a lot of just const incorrect code. Okay, so let's test this page. Okay. Oh, look, it's nothing. All right, that didn't work quite right. So I guess we want to start by checking window storage. Is that a thing? That's not a thing. Oh, okay. Well, I didn't actually expose it. Local storage is a thing, sure. Length 3. Wait, so did this thing actually print anything? No. Or are we dying too soon because of reasons? Okay, first things first. Let's make sure we expose window.storage. Storage. Here we go. And then I actually put it in the wrong directory also, which I have a tendency of doing. It's supposed to be in MISC, so guess, well, name property access should actually work. So why doesn't this work? Are we not running the script maybe? That would be pretty stupid. Okay, I'll do something like this just to be sure. Oops. Okay, well, I messed something up. Forgot about a paren, sure. Yeah, so let's try this again. I think maybe we're not running that script correctly for some reason or other. Or wait, no, we must have been, because it was in, we had length, and the local storage had length. All right, well, at least something came out here. So this is exactly what we got in Firefox, isn't it? 3, 1, 2, 3, 3, 2, 1, name property access 2, and undefined. Cool. So there is our first iteration of a storage object. Let's add it. Definitely a lot of ad hoc code here, but much of it spec compliant with links and everything. And then of course we'll have to continue iterating on it and bringing it closer to where the spec should be. Let's see, I'm going to do that origin thing as a separate commit and then put it before the other one. Commit. Add storage interface and window local storage. This is a naive but somewhat functional initial implementation of storage, web storage, or HTML storage, let's say. Note that there is no persistence yet. Everything is in process and per origin. Yeah. In process only. One local storage object per origin. Yes. Web. Allow using origin. Web origin or origin as a hash map key. Okay, and let me just reorder those. Cool. But yeah, that's pretty rad. And I wonder now if you would be able to see anything different on the Discord page, even with just this bare bones, very bare bones stuff. I guess just for funsies, we could add logging just to see if something comes out. So we'll add some cool colored logging here, storage, just so we can spot it. Storage get item key. They might not call any of these, so we'll see. But I suspect they will at least call. Like the feature check should call something, I would think. Although maybe it only calls the window.localStorage getter. Either way, I'm still gonna check it. Oh. So I think the storage implementation, this first cut, is going to be the thing that we built today. So it's a bit of a shorter video, but still, I wanted to show you some stuff as I continue to work on this, and definitely want to continue to invite other people to participate as well if you're interested. You can help out in many different ways. Like you can look at what Discord is doing and what kind of interactions with our browser it has and what kind of stuff we need to support. And you can also look directly at the browser or at the JavaScript engine, identify bugs, issues, missing features, stuff like that, and either file bugs about it or implement them yourself. Many ways you can participate here. And of course, you can also comment on the video if you learn anything, or if you notice some mistake I made, or if you think of anything we can do better. But for now, let's just try to load it and see what happens if we get any kind of logging about local storage. Oh, look at that. Storage get item token. Oh, shoot. They're definitely interacting with it. That's so cool. Doesn't look any different, of course, but get item fingerprint. You sneaky sneakers. Fingerprinting me? How will you ever identify me when I'm hiding behind this very unusual browser? Yeah, I don't think I have any chance to evade fingerprint detection at the moment. Even if I would spoof my user agent string, the sheer chaos of our feature support is definitely identifiable. Still, it is a bit funny. So yeah, very slow paint and relayout time here, something to investigate later on, but huge progress on local storage. They're clearly interacting with it, which shows that our stuff is doing stuff. Maybe something that would be really nifty is actually to have a way to dump out local storage for the current page. So let's add that as a little thing here at the end. I think that would be really, really good to have. So dump. We have this thing called a debug request that you can send from the browser to the web engine. So, and then the request is like a string basically. So that's how we have stuff like dumping out style sheets, collecting garbage, and so on. So I'll just do something like this: dump local storage. And then web DOM window. Let's see. Should we do it for the current page only? That seems like a vaguely nice thing to do. Only doc window dot dump local storage, or even local storage dump. Just need a handful of includes. Storage.h. We'll add a little API for that. Then we can start a rebuild, and let's see. Just gonna go ahead and add the menu item for it as well. Dump history, dump cookies. So this will be dump local storage. Don't think we need a keybind for it, nor do we have a cool icon yet. But debug request, dump local storage, because it would be fun to see what's in here. So I guess we don't know what our origin is actually, but that doesn't matter here. Let's see, local storage, this many key, something like that. Map size, okay. And then we can do something like this. Maybe we'll even quote these for that good quotey vibe feeling. Okay. Key and its value ++ I and constify and good. Let's see how this goes. So if I'm just going to let it load, but oh, it doesn't do anything. Damn it. Shoot. How did I mess that up? Dump local storage. Dump local storage. Did I mess that up? Dump local storage. Oh, no. It does work. Okay. I don't know why. Oh, maybe it was just delayed. Oh, it was delayed because we were running JavaScript. Oh, okay. I was just not paying attention. So it did work. We have 15 keys, and then you can see the keys here and their values. So they're storing JSON. Very, very cool. And our fingerprint. Look at this. This is the fingerprint of the browser as it is today. Pretty cool. So that's awesome. Let's make sure that we commit the dump local storage menu item for testing. Yep, and yep. Okay. libweb plus browser, browser plus libweb. Add dump local storage menu item to debug menu. Yeah. Okay, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here today and maybe learned something or got inspired somehow. I don't know. I'm certainly having a lot of fun with this project, and it's really fun to see how people get interested in it too. I think it is fun to make a browser. So if you have any interest, come chat with us in the browser channel on Discord if you wanna help out. Other than that, I'm just gonna say thanks again, and I'll see you next time. Bye.